Hey guys, this is Nick from Jenga FX. Hopefully my mic is alright. I was fiddling with it and it was kind of loud whenever I hit my desk and stuff like that. So hopefully it's good. Let me know if it's too noisy and we'll try and troubleshoot. But yeah, so other than that, everything good. Alright, let me ask the chat real quick. All right, cool. So, here we go. GPU particles. Volume is really low. All right, let's see. How's this? Let's see if that fixed it. All right, we'll see. Are we good now? All right, cool. Awesome. A bit louder. Okay. There we go. Even louder now. All right. Hopefully it's good. All right. Cool. So, seems like we should be good now. Awesome. Everybody's saying it's better. So, good. Yeah, I don't know. For whatever reason, my mic and stuff is picking up a lot of hitting the desk and stuff like that. So if you hear loud pops, I apologize. I don't really know what changed with my audio input capture. But anyway, so this is basically EmberGen 1.0. EmberGen 1.0 is not done yet, but internally this is kind of what we're shooting for with this GPU particle build. And so one of the big things here is that with these GPU particles, it's completely overhauled. There's all kinds of crazy new things that you can do with these GPU particles. And one of the neat things is that they have custom forces. You have a particle manager. You can do trails. You can do singular emitters. You can do like spheres as an emitter for bigger smoke. What do you call them? Like squibs and things like that. You can emit smoke from them. You can emit fire, temperature, fuel, whatever you want. And so it's going to be really, really crazy this stream, hopefully, to show you just how powerful this new feature is. This, in some ways, replaces a lot of the emitter stuff that you used to do. But yeah, and so if you want a test build of this, you can join our Discord server, and if you have a license, you can download it in the builds testing channel. And so yeah, so we've released some of the builds, and we'll have a new one coming out soon. I don't know exactly when, but it's kind of a pre-release. So other than that, this is going to be pretty awesome. I'm going to go over kind of all of the new features with the particle system and show you how to utilize this best for your work, and kind of teach you how it works, teach you some of the tips and tricks and secrets and whatnot. And before we get started with that, I'm going to show you a couple of presets. So you can do things like electrical arcs. You can do some really neat just GPU wispy particle simulations, that kind of thing. For instance, just as like a quick thing, we could go in here and change the grouping size to something like 256, and then it's got like these trails and stuff like that. And so we can make it even like a smaller grouping. And so then you have these neat wisps and stuff like that. So there's all kinds of cool new features that you can do with this build. And so then we've got like a furry ball. So we also have proper lit particles. So you can light things with point lights. And so you can see here, we can drag this point light around and kind of go through, go inside, go out, whatever. And so there's proper lit particles. If you wanted to render them in an even higher quality, you can go to the manager and do high quality rendering. And it's going to kind of blur things a bit, but it's going to make them, so that if something's smaller than 1 pixel, the camera can still see it and stuff like that. So this is, pretty awesome stuff, and it's quite powerful. And so just kind of going through these things really quickly. So we've got things like this HD fire. And so what's cool here is that as the particles are moving through this simulation, they're actually being advected by themselves as well. And so if we look at like our active forces, or sorry, injection, we can see that the velocity is 200%. And so what's happening is that as the particles are advected by the sim, they inject their own velocity, and that kind of creates that initial explosive burst here once it kind of builds up some motion. And so that's pretty cool. And then we also have kind of like a little demo, kind of like an explosion, so to speak, kind of utilizing that cascade effect of velocity, and it's pretty awesome. And then we also have stuff like, say, the plasma ball that I showed, and then other things like animating various forces and changing the particle render modes and things like that to give you some pretty neat effects. So, without further ado, let's go ahead and hop in and show you how some of this stuff works, and let's see if we can build some neat effects here on stream. One big thing about this system is that it's going to be able to export to Alembic once 1.0 is actually out. So people for years have been saying, I want my GPU particles as an Alembic file. Well, that's coming. And so hopefully, we can get that working properly, but we are actively doing that. So that's kind of what's going on. So here we go. So the first thing, if you have a new scene, if you want to get your particle emitter to work, so let's say that we wanted to have particles follow this simulation, but maybe what we want to do is we want to turn our fuel off and maybe our smoke rate, and so we just have temperature now, and let's say we want to advect particles with the actual simulation. So we can drag off and create a particle emitter, and then there's two pieces that you need for any GPU particle system to work. You need an actual emitter, and then you need a particle manager. And what this particle manager is going to allow you to do is basically, determine like what your pool size is and how they're going to render in ways such as, trails or a sphere, so kind of like clumps and things like that. So if you want, bigger like explosive trails and that kind of thing. That's what the grouping stuff allows you to do. So you can see if we change this grouping, you get like a bunch of new options. And so, but that's our particle manager. And so if we just go ahead and plug this in, so we have a sphere here, and then we plug our particles into the scene node, you can see that though we have particles inside the actual simulation, nothing's happening. And that's because we actually need to take the volumetric data and plug that into the particle manager as well. And so one thing is we could disconnect the emitter from the simulation, and the reason why this still works is because the particles don't actually need to connect into the simulation. The only time they do need to connect to the simulation node is if, say, say we wanted to emit smoke from these actual particles right here. We can turn up our smoke injection, and you can see nothing's happening right now, but if we plug that in, now all of these particles are going to emit smoke. And so this is really quite crazy, and this is where EmberGen gets super powerful now, because people are always like, how do I, remove this mushroom shape and all this other stuff? Well, particles will allow you to do that by creating some pretty intense effects. And like if we wanted to add more motion to this, we could do something like, velocity transfer. So we'll go here and have each particle kind of inject their own velocity. And so now you can kind of see that it's a little bit more explosive. And so that's kind of the gist of how you get these particles to start. Another big thing that I'll kind of go over just real quick is some of our new modes. So you can see here that the particles are actually sorted within the smoke. So previously, if you had smoke and then you had particles, we had a mode called hybrid where they would like try and render together, but there was no proper sorting. But with this, there actually is proper sorting now. So no matter where you're at, if particles are occluded by the smoke, you're not going to see them. And so that's actually a really powerful new thing about this, is that we've kind of integrated the two renderers together. So with that, one of the next things is we can make these particles emissive as well. So if we wanted to, have particles actually lighting our smoke and things like that, that's possible now, which is really cool. And so, for instance, if we went into our shading node and then we went to scattering, we can turn up like our scattering occlusion. And now we can kind of see that some of the scattering is occluded, and we can see like a value that allows us to change the contribution that the particles are having to the smoke and things like that, which is also quite powerful. And if we changed the color of the actual particles, so say we made it orange, then the color of our scattering would change as well. And so this allows you to create some pretty neat effects here. So let's go ahead and see if I have a quick demo. I thought I did. I believe it's this magic smoke. So this kind of shows an example of particles lighting up smoke, and it's pretty neat. So let's go ahead and create something. I'm not going to go over every single node or like every single thing just yet. I think I might do that towards the end of the stream and kind of step through some of the parameters, kind of show you what's possible or whatever. But I think for now, let's just try and create something like a nice ball of, line rendered particles or something like that. It's kind of hard to explain what I got in my head, but we'll just have to show you. So we're going to go to new project, and then we're going to go in and we're going to add in our particle emitter, and we're going to do just a simple sphere as our emitter, and then we're going to go over here, add in our particle manager, and plug that in. And in this case, I'm not actually going to do anything with the simulator. We're going to use custom forces explicitly from the particle manager here. And so what we can do is we can go over here to forces, and we can do noise. And so now you can see that we have some noise, and actually I want to move this sphere up. And one of the cool things about this is if you're not planning on using any of the actual simulation stuff, so you're not planning on using any simulation data, we can go over here and make this the smallest box possible, and then apply. And now we only have to worry about the actual cost of the particle system, not the cost of the simulation as well. One drawback to this, though, is that if you have lit particles, particles can only be lit within the bounds. But in this case, it doesn't matter because we're going to use a different rendering mode. And so we're going to use, let's see, translucent additive, and then we're going to just do emissive for this system. So it doesn't matter that the simulation box is really small. So now that we've got all these little particles going on, let's go ahead and change our grouping size to something like 16. So we have these little trails. And you can see that there's like a bunch of gaps between these. And so we can do something called super sampling if we wanted to try and reduce the distance between the particle grouping size. And we can also increase our grouping as well. And so now we have something a little bit better. And then we can also turn on high quality rendering, and that'll help a little bit too. And so, but you know what? I wonder if super sampling isn't working. I don't think super sampling is working. So Gil, I see you in the chat. It says super sampling's broken right this second for some reason. But anyway, so we've got these cool little trails, and now we want them to kind of follow the path of a ball or something like that. So let's go ahead and move this on up. And so we're going to go into our active forces. And so with our physics limits, if it's set to 0, it's going to follow 100% of the simulation. And if it's set to 1, it's going to follow more explicitly the physics of the actual particle system. So we kind of have like a weighted average between the simulation and the actual particles. And so then we can change our mass limits here and kind of randomize it a bit. And we can also, increase or decrease the force tightness. So you can see that these particles, they're really following this force noise right here. So we're going to come in as well, and we're going to bring in a point force, and we're going to bring in kind of that repel strength. So just like this. And then perhaps we'll also add in a line, and then we're going to add in some rotation. And so let's see here. We'll just kind of oscillate this line force, and let's kind of bring this up to this thing too. We're going to go back to our particle emitter, and right this second, let's see, we want to change our force tightness to be quite a bit lower. Okay. And let's also turn off my skybox and my ground. And so, yeah, so now we've kind of got this crazy little thing. And we're going to go to our rendering. We're going to set this to white. And then we're going to go to color over life. Okay, so modulation over life. And then we're going to expose our modulation color. And now this is going to allow us to color our particles through a gradient. And we could do something like, you know, maybe like orange to like a, maybe like a blue color or something like that, or some kind of purplish, whatever. And so now, and right now, like we have these trails, and since super sampling isn't working, I'm just going to change these back to follow 1. And that also kind of makes it a little bit faster. And then if we go to our oscillator, we can change this down to something a lot slower. And so now we can see that this line force is just kind of, you know, going along. And so, and if we wanted to, we can change the fall off of this point force, and we can make the repel strength like -50 or something like that, but then change the fall off distance. And so now we just kind of go over here, and we go to the particle emitter and maybe active forces, and our physics limits are probably a bit too high on our mass limits and stuff. Kind of change our force tightness, kind of do that. And so now we kind of have this cool energy ball effect, and it's just kind of a balance between playing with your forces and kind of learning how to fill out like your force tightness and your particle mass limits and physics. And even me, like even I'm still new to this because this is a relatively new feature. But now we kind of have this cool little ball effect with a rotating line force and, you know, some cool repel strength and stuff like that. And if we make the repel strength bigger, we'll get some different effects here. And so it's pretty neat. And if we had made that a trail, it would have been pretty cool, but it's not working very well. So we could also turn off something like our force noise, or we could go over here and we could, you know, change the amplitude. And so you can see that you can get all kinds of neat effects with this particle system. And so this is kind of a cool way to create some neat orbs and all that kind of stuff. So now something a bit more useful, perhaps. This is just kind of an overview to show that, hey, like you can have like differing forces, you can have things not worry about the simulation and whatnot. But now let's actually try and make some stuff by injecting smoke or fire. And why don't we try and recreate our HD fire preset that we had here, so that we can do something a bit more useful, and then show you how to, you know, color fire more realistically. So this is going to kind of go into like some actual shader work and stuff like that too, but this is going to be pretty cool. So if we go to a new project, we can go here and we can turn this emitter off as well. We're going to bring in a particle emitter and a shape, and then we're going to plug in our particle manager. We are going to plug in a volume this time and our particles. And so now you see that our particles are being advected. And one thing that's interesting to note is that even though our emitter right here is turned off, the particles are still advecting somehow. And the reason for that is that if we look at our injection, we have this uniform temperature. So the particles, just by default, they're already injecting temperature. And so for instance, if we, which I don't think there's a way to preview color over temperature. That might be a cool effect that we could do. But regardless, we're going to do some modulation over life right this second, just for previewing. Actually, we don't need to, because we're going to just inject stuff, and we can use the particles as a preview for like where our fire and that kind of stuff is, but ultimately we don't really care. So some basics before we hop into actually making the fire here. So First off, you have continuous emission or burst emission. So you can burst your particles. You can change the burst size. So now we have, looks like 5 million particles here, and we just bursted them. Or we can do continuous emission, and right this second, it's just 125,000. We also have something called jitter distance, which allows you to add, randomness to your shape. So say you have a box, or maybe you're doing something like entangled. So normally entangled is like these neat little lines and that kind of thing. But if you wanted to add a jitter distance, that makes it more like a widened spline. Then we have an emission condition, so you can say, what the particle velocity is, and if it's under a certain velocity, maybe you don't want it to emit, that kind of thing. And then also, like, I'm not really going to go over freeze during this stream, but basically you can emit particles as frozen. So say you have a character and he's frozen or something like that, and then you want it to dissolve as a force moves over it. That's what it will kind of allow you to do. So like if we did this, the particles are frozen, until they're acted upon, by some kind of outside force. And so now you can see here that some of them are kind of getting advected. And I don't know a whole lot about the freeze stuff, so I'm not really going to go over it. But it looks like, you need a minimum force to unfreeze them. So if we had the noise force, you could create like this nice dissolving effect. And so we'll lower this noise force on the particles, and it just gives us a little bit of randomization though. So then, of course, we have like life. So maybe we want to do like 0.5 and maybe 1 second or something like that for our emission here. Maybe we want to do something like 1.5. And so what this is going to allow us to do is not emit fire, forever, throughout the entire simulation. And now we're getting into our actual injection. So, of course, like if we added smoke, you can see that we can inject that. If you did a smoke fading rate, what that means is that as the particle's life decays, so does the emission rate of the smoke. And so say if we wanted to make this decay even faster, we could do something like 1500. And so now they're only going to emit smoke right at the beginning, and then that quickly tails off, which is pretty interesting. So but we're going to change that back to 0, change our smoke emission to 0. And then for temperature, for the fire, we're actually going to do random per particle, so that the particles have a randomized temperature. This is going to give us some more detail in our actual in our fire, because one of the things about EmberGen is if you have a default emitter, right? So say, just real quick, if we pop this back up and we add in a shape or whatever, the temperature here is very even. Like there is no randomness in the temperature. But with the particles, you can actually have it be random per particle. And I believe there's also ways to do it, like position based, which I think uses like a specific noise. So maybe like this part of the fire at the top right, like it might be hot, but at the bottom it's cold. But in general, I find that random per particle is pretty neat. And so now what we can do is like we could just add in some fuel. But the thing with this is that, fuel is kind of, explosive, and like you see it, like it has like this like pulsing effect and things like that. So one new thing here that we've added is you can just inject flames directly. So now we just have direct flame injection, and you can kind of see some of the variation here. So like on the edges, it's a bit cooler versus just one solid color. And we can really utilize this to our advantage. So we're going to go ahead and keep these flames to 100, and we're going to increase our velocity injection. So now you can see this is getting pretty crazy, because as the particles are moving through the simulation, they're going to inject their own velocities, and now we're getting some pretty dynamic fire, which we couldn't normally get with a default emitter. So these particles, they really add in a lot of additional detail. And we can also go to our simulation itself and add in a custom force to give us a little bit more detail in the fire. And so now I'm going to show you how to properly shade this fire. So, I've been working a lot with EmberGen over the past month or so to come up with what I call my HD fire method. And so I'm going to kind of, try my best to match what I've been, playing with, and really show you how to get the most out of your fire. inside of EmberGen to give it, as realistic as I can get it. Maybe somebody else has different methods, but this is just what I've learned over the past month or so. So the first piece of this is we want to go into the shading node, and we're going to go to Flames, and then we're going to change our, we're going to change our fire color to be exposed. And so we're going to do color gradient. And then for our color ramp, we're going to choose exposed gradient. So the first thing you need to do is we're going to make one side completely red. Then we're going to make the other side completely blue. And then in the middle here, we're going to make it black. And so what this is going to do is it's going to allow us to calibrate our fire. Because right this second, like, we don't have an easy way to calibrate gradients, so to speak. And so what we want to see is we want to see some reds and some blues inside of this. So we're going to go to our shading. And we're going to shape our flames from maybe, let's say 1500 or 1700 or something like that. And so now we've got some really bright flames. We can't really see that. And now we kind of see some of the reds coming out, but it's not perfect. So we're going to change our coloring temp here. And now we're starting to see some of the reds, which is really cool. And then we can kind of tweak this until we feel like we have kind of a good range. And so one of the big things is if we look at our gradient, we have a lot of red here. But since the blue is the hottest part, we want to make sure that we only have just a little bit of blue. We don't want a whole lot, because what that means is that our gradient's not very calibrated. So say something like this, there's not going to be much variation in our fire. So we really want to kind of bring that down. And then for our reds, we really want to kind of bring that down. And so now, to me, our gradient is pretty calibrated. And for every fire that you make or simulation, it's going to be just a little bit different. But from here, this is now a really great point to start having some realistic fire. And so one key thing that I want you to note with this is notice that where the color is black, the fire is transparent. And so we're going to use that to our advantage, basically. So we're going to turn off our sky and our ground just so that we can see this good. And so now what we're going to do is we're going to delete our blue. We're going to keep our black over here. And what I found is that by doing an inverted gradient, you can typically get some really good results. So just to kind of start out with, we're going to just add in some colors here, and maybe bring in like a deeper orange or something like that. And then we'll tweak these colors a bit later. But let's go over here and and like I have like some pre-saved gradients and stuff like that, but I just want to kind of show you how I eyeball it at first. And EmberGen 1.0 is going to ship with some custom gradients. So this is starting to look pretty decent. And so you can see that, like, if we wanted, more or less transparency, we can kind of drag this key right here, and it's going to give us some pretty neat results. And so then you could also do something where, like, maybe over here, you have some brighter core or something like that too, and you can really see how flexible this gradient is and how you get like the full range of your gradient, because a lot of the time, at least in my previous streams, we were only using like 25% or 15% of a gradient. But with this new method that I've come up with for calibrating your temperatures, you can see that we can get some pretty neat results. And so, and maybe we want to, lower the difference between those two. So I think this right here is some pretty neat looking fire, and we can kind of change it around if we want or whatever. But I'm just going to kind of stick with this gradient for now. And but I will kind of change up this just a little bit, maybe darken it. And so yeah, so I like this a bit. It's probably a bit too orange or whatever, but that's okay. One other last thing I'll say about coloring here is that you can change your color vibrance, and so maybe do like 0.255 or something like that. And then we can go back to our color gradient and kind of increase our yellows or our whites a little bit, and the scene node's color vibrance will give us more of that orange color that we might be looking for, if that's the kind of fire that you like. Personally, whenever I'm making fire, I like more orange gasoline style stuff, and so I think it's pretty cool. But so this right here is a neat gradient, and so we're going to kind of run with it. And let's see here. Okay, cool. I'm gonna make this just a little bit darker in the center. Sorry. All right, so there we go. I like this. Okay, so now that we have our fire gradient solved, kind of the next piece is making sure that the simulation is doing what I would like it to. So from here, one key other thing I want to show is that we have a new thing as well called force masking. And this is really powerful because if you've watched my adding detail to EmberGen tutorial, you'll notice that I like using force noise to give us extra detail. So like if we turn this force noise off and we restart this, we see that we just kind of have like these like billowing shapes, and there's not a whole lot of randomization and all this other stuff. But now we have this new thing called force masking. And by default, what we're doing is we have just like this constant mask, and it's applying to all channels. But now we have the ability to say only apply force to maybe our temperature channel. And so now what that means is that we can come in here and change our amplitude, and we can apply forces to specific channels. And so typically we're applying a force to, say, our velocity channel. And that's what causes things to get extremely chaotic. But if we want, what we can do is we can, say have just a little bit on our velocity channel, and maybe we want to apply everything to our smoke and to our temperature. And this is going to give us a lot more control over how we're injecting forces into our simulation. And it's going to give us the ability to have some really realistic fire motion and things like that. And I know that in other tools they might call them like a micro solver or whatever, and that's kind of the idea behind this kind of stuff, is adding new subtle forces to your simulations. So we've kind of got that, and you'll notice that we are hitting the bounds a lot. But before we get into solving that problem, the last thing I want to do is kind of change how our emission is going here. And perhaps I want this to be a little bit more explosive. And so if we go over here, so let's see. So the range of the physics type particles with a physics of 0 will follow 100% of the simulation flow. So we want the particles to follow more of the simulation, so it's a bit more violent. So some of them are going to be slow, some of them are going to be fast. So now whenever we do this, boom, it's quite explosive. But one thing that I don't like is how we've got kind of like this like line of emitter stuff and whatever. So we're going to go over here to our emitter. We're going to go to emission. And I think that the emission rate is fine, but maybe we want to do clumped so that they kind of clump together, but it's still random enough that you're not really going to notice. So now that we've got that, one of the next things that we might want to do is fade the temperature over life, because you kind of see how we've got like these singular particles going through and emitting temperature and things like that. So we could do like a flames fading rate, and that's going to give us a little bit less fire. So maybe we don't want to fade flames that much, but maybe we do want to change our temperature and really fade that as well. And you kind of see that this is going to change the way that our fire looks. So you really do kind of have to play with this, but theoretically the temperature ranges might still be the same. But say you do change like your fading rate, that is changing the overall temperature of the simulation, and you kind of do have to kind of go back and recalibrate. But then that's where this color remapping value is going to come in. So you can leave your calibration the same, but just kind of change your ramp until you get the look that you're looking for. And so say we wanted to go something lower like this so that we're getting a lot more transparent values, but you want it to be brighter, then you can change your shaping flames, and that's going to give you something that's maybe more akin to what you are looking for. The next piece that I'll talk about is kind of the combustion here. And so with this, there's a lot of smoke and it's kind of lingering around and all this other stuff. So we can go over to combustion, and we could change our smoke dissipation to be higher, Or what we could do is we could just lower the generated smoke to something like 0. Then we only have fire. So like in this case, you can kind of see that we do still actually see our particles. So one of the cool things is that we can go into the rendering mode. We can go to render particles and then just turn that off. And now we have some pretty good looking fire. So now let's go ahead to our simulation size. Maybe do 256 by 256 cubed. We'll hit apply. And so now we have something like this. And it is a bit slower, but there we go. So there's some pretty neat particle stuff. And so one of the other things is that we kind of have particles that are the same size, and emission is based on the particle size. So we had like those big extra like sparky looking bits and stuff like that. So we can just modulate this over life. So this curve right here is going to determine the size over life. So if we did something like this, they're going to start out small, then they're going to grow, then they're going to kind of come back down. And if we wanted to make that, you know, a cosine wave or cubic or something like that, we could go in here and change those types of things. So it's pretty neat. So we're just going to go back to our preset. And we also have these cool little presets here so that you can try some different things just kind of on the fly and really change up your simulation. And so now we can go to our bounds, kind of see that maybe we went a little bit too big. So we can do maybe 196 and apply a new resolution. It's just so that we're going a little bit faster. And of course, one of my hot tips is you can press U on your keyboard to do unlit rendering. Let's make sure this is actually working, which it is. And so so there you go. So that might speed it up a little bit. Or you can press like Control 1, Control 2, and Control 3. Control 3 is going to be like our highest quality renderer, and Control 1 is the lowest quality. But I typically like the lower quality for previewing and speed and all that. So now we have some pretty neat fire, in my opinion. And if we wanted to make this just maybe a little bit better, we could go over to our volume, and we could either do like some sharpening on our flames. So we just change this to sharpening. We could, you know, sharpen our temperature, or we could just sharpen the flames themselves, kind of give us a little bit more detail if we wanted to. Or if we wanted to as well, we could go in here and do a post modulation. We're going to do maybe say vorticity as our source, or actually maybe let's do noise as our source. And we're going to choose flames as our thing. And we're going to do say maybe add sub. And then we're going to mask this with the flames channel. And so then what we can do is we can just pause the simulation, and we can change our target range to -200 to 200. So that's going to give us some dark spots and some bright spots. And then we can change maybe like our octaves, kind of our noise scale. Maybe we want to lower our advection intensity to something like 69 or 70. And then after this, we can kind of change like our gain. Now you can see that it's going to give us a bit more detail as well. And we can kind of play this, and now we have a bit more detailed fire, but you know, maybe it's too grainy or whatever. So, you know, you can kind of pick and choose, you know, your noise here. You know, we can go over here and kind of add like differing curves and that kind of stuff. So this is just kind of another option to inject, or not necessarily inject, but post-process your volume in such a way that you can add, you know, new additional detail. We could also go over here and add, say, something like, you know, vorticity as the sampler or whatever as our source. And so now you can see that we kind of have a much different effect. We could also do something like multiply if we wanted to, and really kind of change out, you know, how this is working. So post modulation is a complicated topic, but basically you pick a source, you pick a target, you choose how you want to operate on that data. And then you kind of choose your target range. Typically, I always go -200 to 200, but it's kind of up to you. And then we choose a masking source, typically, because if you don't, you might have some kind of effect like this, and it's typically not going to be what you want. So yeah, so we'll go ahead and turn that off. But so that just shows, you know, really quick how you can get some neat fire with this. And the difference between this is if we went over here and we just went to emitter and shapes, you know, we might have something like this. But the problem is that if we go to visuals and you know, whatever. So we're not actually showing the emitter here. You just have like this round ball, and it's really hard to, you know, remove that shape, and it's just not really possible, even if you're injecting something like noise here. So it's just not as good. You can still see that round sphere or whatever inside there. But if we go over here and we see these particles, it's giving us so much more additional motion, which is really neat. And so one last thing that I'll say about this particular effect is if we did something with our particles specifically, so say we wanted to add in a line force and then twist this, the actual particles will twist, and then those twisting particles will inject the velocity into the simulation, and we can do something like a repel strength to kind of bring those back in, maybe do something like 15, so something crazy. And so then you can do some really cool emitter tricks and whatnot with differing forces, and it's only being applied to the actual particles, which is just really powerful. And there's all kinds of neat things that we can do. So maybe we have this, and then we also come in and we add in like a point force, and maybe we want to you know, attract these, so we'll do something like, you know, 100 or something like that, and actually we'll do negative 100 to attract. And so then we have, you know, some kind of crazy atomic looking particle effect or whatever. And then maybe we could bring up our shape primitive and kind of add that in. And then if we want to, we can kind of see that maybe we're not getting as much, you know, temperature injection as we would like. So maybe we can decrease that fading rate. And yeah, so we just have some really interesting effects that you can do. So that kind of shows off, you know, building fire effects with, you know, particle systems, and we kind of added, you know, some smoke and things like that. So we can go back here and maybe change our generated smoke and reduce our decay rate and all that kind of stuff. And so, and then we'll go back to the HD fire, and then we can just kind of look at this gradient. So it was a lot brighter of a gradient, and then it looks like we had some pretty high shaping flames, a little bit different remapping. And then with our particle injection, looks like we went up to 8,000 with the temperature, versus with the old one, I think it was like stuck on 4,000. So if you want brighter flames and maybe a bit more variation, and especially, you know, more variation in temperature, if you know, go from 0 to 8,000, so some particles are completely cold, which is pretty cool, and can add in some more variation. So so this is, you know, pretty neat. And so all these presets, whenever 1.0 comes out, these will, you know, be in that. And then I think if you have the particle build now inside of our server, you know, I believe this preset's in there too, and you can take a look. So one of the next things is, let's talk about making something like falling dust. You know, typically, right? So let's say we wanted to make falling dust or whatever. We can go over here and we'll create like a box. And so we're just going to do kind of like a real quick thing. And maybe we want to have no emission of our temperature, no emission of fuel, and maybe we want to increase our smoke rate. And then we would do something like go into our simulation. We're going to go to forces, and we really want to bring up this smoke weight. And so now we have like this falling dust, and maybe that's a bit too much. And so boom, there's falling dust. And we go here, and we block our ground as well, and boom. So there we go. And let's go ahead and maybe go to our sim size, 256, 256, apply, maybe do like 196 to kind of give us a little bit more speed. And so there we go. So now we kind of have like this falling dust, but in my opinion, it's quite boring. It's got like, you know, really puffy bits, and so like we'll go over here. So it's really puffy, and it's kind of slow, and all this other stuff. So, you know, if you think about falling dust, you know, what is it? Typically, it's a bunch of small particles, right? And some of those small particles have like clumps, and they're pulling more dust along with it, and all that kind of stuff. And this looks more like dry ice. So if you're going for a dry ice effect than just a basic emitter like this, it's probably what you want to go for. But of course, this is a stream about particles, so you know where we're going. So we're going to go over here. We're going to delete our emitter. We're going to drag in a particle emitter. We're going to go to shape, primitive. We are going to do a box again. We're going to kind of drag this up. something like that. And maybe we want to make our Y quite a bit longer. And then we want to just make sure that we bring up our particle manager and then plug that into our shapes. And so here we also want to inject a bit of our actual simulation data into the particles for a bit of extra advection. But one of the key things is since this is a cold simulation, we want to change our min and max temperatures to 0. And the reason why we're still going to plug in the simulation into this is if we go here, and so this is actually going to be a really good example to show, kind of how we can take these particles and add in additional advection. So if we go ahead and inject this, so there's no actual velocity happening in the simulation right now, but if we start to inject velocity here, now you can kind of see that they're creating some pretty interesting disturbance, and because the simulation is blocking the ground, you can see that some of the particles are following that as well. And so, but we definitely don't want that much. We want just a little bit of variation. Then we can go into our forces. We're going to go and do noise, and we don't want as much there either, so we're going to go to active forces, and actually we're just going to change our amplitude a little bit so that there's not as much effect. But this is going to give us some nice little streams of particles kind of coming out of this box. And one thing, if we wanted to, that you can do, because the particle emission isn't dependent on the bounds, is we can have the actual spawn shape be outside of the bounds, but then have our particles just kind of fall through as a bit of dust. So now we want to go to our injection, and we could go through here and just add in some smoke injection now. So let's just change it up to like 100. And so now we have this, which is pretty neat. And so now you can see we do have quite a bit more detail, especially on these like streamy particles and whatnot. And this is a situation where we would probably want to just burst our emission. So maybe we just want one big burst, and then boom, these particles kind of come through and they fall down, and then, whatever, they fall down and do their thing. So one of the next things I want to kind of change up is our shading. So, one thing that we could do is we could use these particles to our benefit, and we could come over here and maybe change like our particle coloring. And so we do have to kind of reset them, and maybe because one unfortunate thing is that the particle color won't update unless you restart the simulation or a new particle is spawned with that color. And so we could kind of use those to our advantage. And so say if we went over here to rendering as well, or actually shape, and then we did say something like velocity aligned, now we kind of have like these velocity aligned particles. It kind of helps add like a little bit of extra detail to the simulation if that's something that you were going for. But in this case, you can go to rendering and just turn rendering off. And so in this case, they also can cast shadows. So you can have your particles still be there and cast shadows onto your volume if you want for additional detail. And so you can kind of see that if we go up here close and we turn it on and off, you can kind of see here at the bottom the particles casting or not casting. But for some really cool looking smoke, why don't we go over here and go to color ramp. We're going to change our min color to something, maybe rather bright, and then this to something a little bit darker. And so something like that. And then we can kind of change like our color ramp if we want to. And then what we can do is we're going to change our smoke density to something quite a bit lighter. So maybe, 23 or maybe 13. And so now we kind of have this stuff kind of coming through, and boom, we've got this really cool thing. And because of the way that the simulation is going, we can see something cool is happening to the particles. So as the smoke is starting to bulge out, you can see it starting to advect some of the particles and push those out too, which gives us a bit more realism. And so one of the other things though is that we're probably emitting, way too much smoke. So we can go back to injection. Maybe we bring this down to like 31% or something like that. and maybe get us something a little bit more realistic. And so there's that. And then one thing is we probably want to up our vorticity to quite a bit. So maybe like 62. We also want to go to forces and do our force noise on this. And that's going to give us a lot more detail. And in this case, I'm going to keep my constant. So I'm not going to do any masking here. But what I am going to do is I'm going to actually take some of this. So let's see what I'm looking for. Okay, amplitude. So we're going to animate our amplitude. So do that just by clicking the little circle. We're going to go over here and we're going to start it off at 4 and then it's going to go to 0. So now the simulation is kind of preloaded with some neat velocity and vorticity, but maybe we want to kind of bring that down quite a bit. So here we go, 2, 0. Okay. So there we go. So now it's kind of preloaded and we do have some neat details and some neat vorticity. And now that's giving us quite a bit more detail on our smoke. And then one of the last things I'll kind of show to give us some extra variation in this is we can see that the particles, they're just kind of falling, well, first off, they're kind of falling against the bounce. So we can kind of not change our position, but change how far on Y these are emitting from. And so now we can see we're not really hitting the bounds anymore, so we have a bit more room to play. Maybe we want to bring this down to something like 10 as well. And so now we kind of have all those particles going through, but we can actually do some initial force here. So we can do something like an initial range and, maybe go like -20 and then, maybe some positive and negative in those different axes. It's probably a bit too fast, so we'll just do -3, +3, maybe just 0, and whatever. And then we can also go to rendering and then just kind of see what these particles are doing. So you can see they're kind of going up and then flying through. It's probably not what we want. We'll just do 0 on that. And maybe, we'll just leave it like that. So now we have a bit more variation in the actual particles. And so, but this is an instance where maybe, just maybe, something like clumping might be of use to us. So we could go over here. We could do, say, a group size of 64. And of course, we could emit from some weird trails. But we also have a method called spheres. And we can stretch these spheres if we want based on the velocity. And so now if we want to, we can go back to our rendering, kind of turn those rendering off. And now you can see that we have these kind of, randomized spheres or whatever. And they're just kind of falling through. And that gives us those thicker trails that you might want for something like explosions or what have you. And one key thing to note is that if we change our shape here of the particles, some of those spheres are going to be large and some of them are going to be small. So if we wanted smaller spheres, we're going to do 0.01 or maybe 0.005 and maybe 0.01. And so now we can have spheres that are a lot smaller, but they're going to be groups of, whatever amount of particles you set. So in this case, 64. You could do, say, 8 if you wanted to, or just kind of, whatever you're interested in doing for your simulation. If you're like, hey, maybe it's a bit too much to have, just individual particles emitting or whatever. But you can kind of see that, part of the downside is the more you clump together, they're going to emit less smoke and that kind of thing, just because of the voxel size that you're playing with and that kind of thing. So that kind of goes over using this for something like a falling dust or whatever. And then in this case, because we have not as much emission or whatever, since the particles are more spread out, this might be a use case where you do something that's maybe a bit more constant, or maybe we come in here and we go to active forces, and maybe we change this to be full on, and maybe we change like our gravity intensity or whatever. And so you can just kind of like play around with this and get differing shapes, or maybe we want to inject a lot more velocity into this. So in a lot of cases it was like, hey, like there's not a lot of motion, so we can go over here to active forces, change that back, kind of change this over as well. And so now we're injecting a lot more velocity in this case. And so, but one other thing is that you do notice that this is quite, uniform. And then that's where something like, emission in, say, entangled would come in. So if we go back to rendering and kind of see this, you can kind of see that it's going to give us some different randomized clumps and things like that, or maybe not clumps, but strings. And then we could do something like actually clumped, and maybe that's a bit better. But because we have these initial forces, they're kind of going to break out of those clumps. And so maybe something more like this is realistic, where you have like these clumps falling through, and then they start getting infected and things like that. And so, yeah, it's pretty neat stuff. So if anybody has any questions about this, go ahead and start typing them in the chat. This is literally, like, the stuff I've shown, like, it just scratches the surface on what's possible with this new particle stuff. And you can kind of see just how cool these particle streams are. So if we go back to like burst emission, we can just burst some, and then boom, we've got like a really neat falling dust effect or whatever. And then we can just go over here and shade this, and maybe make it so say go to like our scattering and kind of maybe bring this up, maybe make it a little bit more on the orange side like dust, and then maybe bring up like our lighting intensity, go to shading, and maybe we want to let's see, make our sharpness really sharp, maybe increase our ambient occlusion to bring out some of those details, maybe increase our smoke shadowing density. And so now we've got some pretty neat looking smoke there. And then of course we can go over here to like our volume. We can post-process this with some sharpening. So if we wanted even more detail, but we are kind of getting some voxels there. And so if we want to, here's one thing I'll do, is we can maybe have some, we'll shoot for something like really realistic. So we're going to crank this size up. We'll do something like, say, 450, and I don't know, maybe like 250. Let's do 300. So I'm going to push my 3090 kind of to some new limits here. And it's going to be kind of slow, so hopefully the stream works out well. But what we can do is we can increase the size of this shape fairly tremendously. We can go to our particle emitter. We can change our burst size to like 5 million, so just maximum particles. And then we can go over here and kind of bring that shape up a bit. And now we have something like this. And so this is going to be much higher detail inside of our simulation. And we can turn off our sky. Actually, let's leave it on because it does give us some cool coloring. And so there we go. So there's a much larger simulation or whatever. And in a lot of cases, like this is, so you can see that that's getting really detailed, which is really cool. And so that's just, increasing our volume and then making sure that the emission covers more area and that kind of thing. And you can get some pretty cool results. We could go to shading and kind of maybe reduce our actual, so let's go to smoke and kind of change our actual density clamp. So maybe if we wanted something a bit lighter, so that you can maybe see through more of it or whatever, you can do that. Yes, 1.0 will be the next official download. If you want these features early, you can buy a license and you can get them from our Discord server in the testing build channel. And it's a private channel for licensed users. So yeah, so this right here gives you a lot more control, like I said, over kind of how your particles are behaving and whatever. And in this case, if you wanted to, you can like increase your particle life or not, or just whatever. So this is just, really, really cool ways to, kind of do stuff. And then if we wanted to, like, let's go back to like a small size. So let's do like 192 or whatever. And we'll just kind of, play this back. If we did want some additional variation, even though it, might not be realistic, is we could also, still inject temperature into these particles. and that's going to make sure that it's a little bit more chaotic. So we can go over here and let's just do something like 8,000 and kind of see what it does. And so probably want to go to active forces. Yeah, so now you can see that some of the smoke and stuff is rising. So that's probably not what you want. I figured it would probably affect the particles a bit more than it did, but it didn't. But if we did do like particle physics limits, and then we go back over here and we go to maybe rendering, and then render these, and we do something like emissive, and then just additive, so we can kind of see that when those particles hit the bounds, some of them are going to probably start trying to fly away and go back up. So yeah, that's what some of them are doing. So that's just kind of you know, what's going on with the particles there. So let's open up a cool preset. I'm going to go through and answer some questions. Let's do water ball, because it's really a cool example of kind of what you can do with this stuff. Let's turn off our high quality rendering so it's a bit faster for the stream. Okay, so kind of going up. Right this second, yes, particles are only usable inside of EmberGen with its integrated renderer, but we are working on Alembic exports. 1.0 is not available to download. 1.0 is going to include quite a lot of other features, like a completely reworked exporter. So like, you know, these nodes, they're going to kind of disappear and be merged into one. And then we're going to have, you know, the ability to have like multiple cameras and all kinds of crazy stuff. But, and of course, you know, no ETA on 1.0. But if you do want early access to all these features while we prepare for 1.0, then like I said, if you're a licensed user, you can join the Discord, get the tag, and you'll have access to it. Let's see. Yeah, so I said I have some solar flare stuff with the particle system. Yeah, you're going to have to probably convert stuff. So Jason did say like it should still work, but if it's the old particle system, it might not. Honestly, there's way too much that's different. And with 1.0, you're probably going to have to recreate a lot of things anyway, because we're changing a lot of things, but we're hoping that from 1.0 forward until 2.0, things within the 1.0 range, or just version 1.x whatever, they'll all be compatible until 2.0, which is when we're going to introduce Sparse and Linux and Mac and stuff like that. So unfortunately, Linux and Mac isn't going to come to 1.0 just because that's going to be dependent on our rewrite for Linux and whatnot. And I can, while I answer some questions, I can make myself bigger. All right, so let's see. No news on the Otoy stuff. Any other questions here? Has Epic Games been cooperative regarding support for the baked volume textures, or have they turned their back in favor of Niagara Fluids? They may or may not have turned their back on it. I know that we want to support baking out volume textures, but one thing that you can do now is there's a new plugin from IDOS Montreal. You can just type in Unreal VDB plugin into Google, download it on GitHub. And actually, if you look in the description of this video, you can see our volumetric cloud system running inside of Unreal Engine 5 with that plugin. So that's really cool. And actually, it uses Unreal's volume slicing stuff. So the plugin isn't even like running in that project, but the volumes from EmberGen are. And if you look on our Twitter, there's a lot of cool stuff from Unreal Engine 5 and volumes. How do I limit the timeline to a specific number of frames? If you go to simulation, time control, actually, yeah, and then you go to repeat simulation, you can do, say, 128, and then boom, it's limited. It's never going to go past frame 128. Somebody said very impressive. Thanks. Yeah, I don't have a process of rendering through Cinema 4D or anything like that. I exclusively use EmberGen's renderer, since you're not going to get any of our stuff to look as well in other renderers. Just because you have so much additional control inside of EmberGen, and the workflow that we advocate for is to render everything in EmberGen, and if you need holdouts, you have your holdouts and your meshes and stuff blocking what you like, for depth and stuff like that, and then you can posit it, in another program. We might have event-driven particles, but I'm not sure. That's a bit on the difficult side. And mesh particles may or may not happen. I'd go with probably not, but EmberGen has a long way to go, so I'm sure it'll probably be an option in the future, though. Let's see. Anything else? Yeah, so somebody said particle colliders possible. I'm not sure exactly what you meant, but you can have specific colliders. So like one demo project that we have is this sand stream. So you can see that there's a bunch of sand particles kind of going out, and then they're colliding with this collider, which is really really neat. And of course, it's injecting a lot of smoke and whatever. And so this is kind of a cool way to collide with particles. And in this case, the smoke is colliding too, but say if we wanted the smoke to go through, but only the particles to collide, you could do something like that. And then if we go to our particle emitter and then collisions, we can change like the bounce randomization and the bounciness. So you can have some really explosive collisions and stuff like that. So there's a lot of really cool stuff in terms of colliders and just what's possible. And so you do have like, particle collision randomization. So like in this case, it's just going straight like in the vector that it was in, but you can randomize that vector. So it gives you some random, rotation and whatever, which is really cool. What year would EmberGen become available for Mac users? I don't have a year. Whenever EmberGen 2 is out is whenever we're going to do that. I know that we said EmberGen 1.0 would have Linux and Mac, but unfortunately Sparse is just a very, very large task, unfortunately. And so, it's pretty crazy. And unfortunately, we have no timeline on when that's going to take. Just like LiquidGen, we literally do not know when that stuff is coming on. And we have two separate teams working on both products. So I said, yeah, this is impressive. Good hard work there, guys. JingFX. Thanks. Our team is busting their butts to make some really cool software. Can you generate deep renders out of EmberGen with our new export workflow? So, like I said, we are completely redoing the export workflow. Like, there's so many like bugs and glitches and just like, wow, like why can't I do this thing and just all this other stuff. Like we're gonna completely redo everything for 1.0. And so like scaling stuff for VDBs is going to be fixed. Mesh alignment is going to be fixed. And we're just making sure that every single export is exactly how it should be. And hopefully, fingers crossed, it'll be like a dream come true export workflow. So that's really what we're going to call EmberGen 1.0. And then like the big new feature that we're adding around it is these new GPU particles. Now, somebody said particles orbiting a sphere. We kind of have something like that, where if we do, like there's like particle swarm. So we have something kind of like this. It's kind of got like, I guess it's like a point force. Yeah, so we kind of have like a point force, and we can change the scale or whatever, and go over here and change the tightness. And if we wanted this to orbit a sphere, I guess what we could do is we could add in a collider. And so let's go here, shapes, shape primitive. We'll do like 2.3 or something like that. And maybe turn off my force noise. but then we'll go to the actual collisions, and we'll turn off our bounciness. And let's see. I think I should probably emit on the surface. Make sure this is... it's emitting from shape noise. Oh, no, that's a mask shape. I wonder why that's doing that. 2.5. Let me try my point force. It's kind of weird. I don't know what I did to break my emission. Okay, always. There we go. That's what was going on. And then we can just do, let's go here. How do I change my position? So I guess this is 0. There we go. So we'll just do, say, 6, and then we'll go to our thing here, and we'll do 6. And then we'll go to our collider, make sure that's 0. So now they're the same, and if we wanted these to orbit around a sphere, I guess what we could do is, at least what I would do, is I'd come over here, add a force, we'll do line, and then instead of push, we'll do twist. And so there we go, now they're kind of orbiting around the sphere. And if we wanted to make sure that they aren't going inside and stuff like that. So we kind of have this, which actually let's just kind of keep it there so that we don't see through it. We'll make it like a darker sphere or something like that. And then finally, we could maybe do our point force. So see, you can repel it or you can bring it in and do like -5 or something like that. So then if we want to, we can increase the twist strength or whatever, and some of these particles, they are colliding, so maybe we want to do something with our collisions and maybe like reduce the friction or something like that if we wanted to. And so you kind of have like this interesting sparky ball or whatever, and then if you remove the collider, that's kind of what you get. So the collider is important here, but hopefully that answers your question. How would you get particles to kind of orbit a sphere or something like that? I would probably make a collider and do something like this, and there's plenty of things you could probably tweak or whatever. Or if we look at like our lit particle example, where are you? Stream. We'll actually go to Jenga effects, and I know what I'm looking for, but I just can't think about it. Server builds, EmberGen particles, presets, and then it's this it's like the light ball or something like that. Sorry, I have like a trillion presets, unfortunately. Maybe I'm in the wrong spot. Water ball. There's a specific one that I'm looking for. I don't know what it's called, unfortunately, but it was really nice. It was like a nice swarm of whatever. So open project, don't save, and we'll just open up what's it called? Oh, shaded particles. There we go. So kind of like this. So this is also kind of something like particles orbiting around a sphere, which is really really neat. And so you can see that some of these particles are kind of, they're hitting the bounds and stuff like that. But what it is we have like a line force like actually affecting the simulation, and then like it's really cool because particles are just kind of like being like ripped from the sphere and all this other crazy stuff. And we could like lower the scale and maybe increase like our amplitude of noise, or do something like say 50 or whatever we want, and just make it like really crazy and chaotic and all this other stuff if you wanted to. But it is really, really neat what this new particle system stuff can do. Yeah, we don't know what sleep is. Somebody said, do you sleep from time to time? Yeah, we sleep. We don't do crunch or anything like that here. And so we just work our 40-hour weeks, basically. For the most part. I'm sure that some of us probably put in a little bit of extra time. I do, typically, but most others, I Hopefully they work 40 hours. I tried not to get them to do more than that. Yeah, so somebody said, can you explain simulation scale for a newbie? Okay. Yeah, so very, very, very easy. Basically, all you need to know, and this only applies to this version of EmberGen. With sparse, this is all going to go out the window. But basically, say we have something 32 by 32 by 256. Our problem with this is, let's do like a sphere, is we have the simulation is really fast, but we have a very, very small bounds for our smoke and stuff to be in. And so if you wanted more room, basically you come in here and we do say something like 192 by 192 by 256. We would click apply, and there we go. Now we have more room for our simulation to be in. Truth be told, a lot of people try and change the voxel size, but it doesn't really do anything. It doesn't truly work like you might hope or expect it to. And so that is unfortunate, and sorry. It looks like my camera was covering the thing. So I went into the simulation and changed the voxel count here, and then you click the apply new resolution, and then that's gonna change your scaling there. So yeah, so that kind of goes over the simulation scale, and I do want to kind of show you guys something a bit secret if I can. It's not actually secret, but it's really cool if I can find it. Let's see. So what we're going to do is I'm going to launch this. Let's see. Okay. I think that this is it. Let's hope so. And then we can do something like this. We'll just drag this joker over. Okay. So this is so let's close out the other EmberGen for a second. So kind of here's a quick preview on what's coming and what EmberGen 2 is going to be. So for transparency, we kind of have three teams here at Jenga Effects. We have the team who's working on 1.0, and then we have the team who's working on 2.0, and 2.0 is a complete rewrite of EmberGen on the simulation and rendering side. And the reason why we want to do that is this. There are no bounds. You can have an infinitely sized simulation if you want, and the detail is much greater. This is, no shading or anything like that. Like there's no lighting information yet. This is still a lot of testing work. But if we go over here and then we say move our emitter, like we have very rudimentary stuff going on. But say if we go here and we move this, we can see that we can just keep moving it and moving it and moving it. And so we can do, say, up to 200. And so then we can just kind of come down, and it just keeps on chugging along, right? And so it's really cool. And the thing is, what's even cooler about this, right? And so if we go back to our one little preset that I do have here, I don't know where my my custom build is with all my other presets. But if we do go here, our simulation size actually works. So say if we do 0.5 as our voxel size, it's going to be extremely fast. So it's extremely fast. It's low detail, so we can even do say something like 2, and you're getting like on the per voxel level. And I don't know. So you can see like our bounds here, but then like this giant red box that you see like kind of in the background, that just big line, which we can't even see it because of the ground here. And it looks like our sky and stuff is kind of borked or whatever. But it's just crazy because you can actually change this, and it's going to be like the same velocity and stuff like that, but you can just add more detail. So you're like, hey, man, I really want some more detail. Let me try, 0.5. Okay. Well, let me do a little bit lower. Let me try 0.2. Can my computer handle it? Yeah, okay. Let me do even more. Let me do like 0.1. All right, well, I you know what? I want even more detail. Let me do 0.05. So now we're starting to get on the insane level of detail. over here, where I mean it's just, you know, a lot of really cool stuff. And so you know what I could do, I think, is I can drag this. So let's don't save. Oh yeah, so here's like a good example of you know, sparse stuff. Ignore like our rendering and whatever here, but you can see here we've got this big trail kind of comes through, and then boom, you know, whatever. This is just something that wouldn't be possible in the current EmberGen that we have. And so this is why we have another team working on this. And then the cool thing is I mean, this simulation is just, I mean, it's gigantic. It's massive. But notice that the UI is still completely usable. So we have something called preemption, and just everything is just super fast. The renderer is blazing fast in this case. It doesn't matter how slow the simulation is chugging or whatever. It's just going to be you know, some really amazing stuff. And then we have something like you know, this. And so unfortunately the ground is kind of like bugged out in this build. But you know, so like things aren't really showing like underneath or whatever, but it's pretty neat. So you can see the sim is chugging, but everything is still you know, completely interactable, which is just like I said, it's just insane. Let's see, I have like a couple of you know, interesting presets here, and I really like this one because like it, which actually, you know, let me see if I can you know, load this version of EmberGen where all this stuff is working properly. It's a bit older, but we can do, say, like this, the tendrils, I believe. There we go. Okay. So now you can kind of see like this cool like vortex that it forms and stuff like that by, you know, kind of swiping through or whatever. And if we wanted more detail, you know, we could just come in here and do like 0.2. And actually, it's probably a bit too fast. So there's like a bug where if you go like past a certain voxel size, it's just too, like what would you call it? Like it's it's too fast for like the small voxels basically. So that's why we had like a problem there. But it is just really cool to see, you know, what this stuff can do. So that's kind of the extent of my you know, all of my little presets that I have here. But it's just really cool to see kind of where this is going with our sparse simulator and kind of what's going to be possible and whatnot. So yeah, that's kind of, as far as I know, that's probably going to be the end of the stream. That's a bit of a showcase of particles and kind of how you can do which let's open that build back up if we can here. So Django FX, stream, new particles, open you back up, and very quick to load. Oh shit, I just closed it. There we go. Ta-da! So we're back, and so yeah, that's kind of a cool new thing that's going on with EmberGen and what we're doing. You know, particles are crazy. They can be lit now. They can be emissive. They're additive. They can blend with smoke. You can very quickly come in and just you know, inject. So say we just wanted to inject some fire or something like that, we could just come in here and you know, make sure that the volume node's plugged in too, and then boom, like we've got you know, flames along with a bunch of particles or whatever, you know, or we could just come in and maybe do a little bit of smoke injection or something like that if we wanted it to be, you know, a bit more hazy or magical or whatever. So we have proper rendering passes for all of this stuff, and it's going to be really, really awesome. And you know, one thing that I am interested to see if I can show just real quick before we hop off is maybe some of our UI mock-ups for our exporting stuff, because you know, the thing is with the exporter there's a lot of problems, right, where you know, like you can't like name like all these paths and stuff. Like if you go here and you clone this stuff and whatever, like now none of this stuff is going to be synced unless you like select all of it, and just like you have to choose like the stuff that you're rendering, and then like you go over here and so we select all this and like auto link it. Now it's just kind of messy and all this other stuff. So I'm gonna see if we have an example of some of our new mapping and whatnot. And so looks like we do right here. And so let's see. So I'm just going to kind of bring this over. So you get a little bit of a sneak peek on our Discord server. But here we go. So like this is just showing like how the new export system is going to work. And, you know, I'm going to pause it right there whenever it kind of, you know, uncollapses or whatever. So this is kind of a sneak peek at our exporter that's coming up, where you'll be able to redirect, you know, any of the nodes anywhere you want. And this is going to be a really powerful system because you can change the background color. You can choose whether they're HDR right there. And then like things like the render setting tab, for the most part, is going to kind of disappear. And you notice that the exporter is built in to this node. So you'll have, which let's see if I can find another thing here, which it's pretty cool. I probably should have gathered some of this stuff before the stream, but yeah. So we have stuff like you know, kind of like this, where you know, say we go over here and we see this. So this is kind of like what the export tab is going to look like. So you can choose whether it's a flipbook or a sequence. You can choose what camera you want. You know, instead we're going to have like a directory and then like the actual export piece. What do you call it? The file extension. You can have a prefix, and then the file name can just be the project and all this other stuff. And then like you see like the final, you know, name and whatnot. And then we have, you know, first frame, last frame, all this other stuff. But the key thing is that, say, you'll be able to export, you know, one thing with like a certain flipbook size, and then another thing with a different flipbook size, and you'll be able to do like multiple camera exports and all this other stuff all at the same time. And then you'll also be able to save these out as presets and whatnot for your exporter. So you can just kind of see like this is our mock-up or whatever. But yeah, so it's going to be really powerful ultimately, and you know, I'm really excited to see where that goes with our exporter. And it's going to get rid of this whole like wiry mess and having to click and, you know, rename all this stuff and just, you know, whatever. So it's going to be excellent, and we really want to make sure that things look good. And so with that said, I guess the last thing I'll say about that is just with like, so say, notice like you go to the render, you have like these common parameters and like HDR and background and components and like 6-point parameters and all this other stuff. When you go to the render thing, this is going to be a new panel, and you'll just have all your options here in your actual render view, so that things are a lot, you know, more condensed and whatever. And then we're going to be fixing most of the bugs with exports and add most of the export features that have been asked for. So that's basically going to be what 1.0 is, along with this particle stuff. So it's really quite neat. So hopefully you guys learned a lot today, and just kind of got to see a sneak peek of, you know, how you're going to work with the new particle systems and whatnot. So I'm really excited for everybody to get their hands dirty with this kind of thing. And I'm going to just answer some final questions, and then we're going to shut the stream down. People have tried to make a black hole in EmberGen, yeah, but you'd have to do some post-processing for a lot of it. Let's see, anything else? Somebody said the UI still tries to render at maximum FPS. I think it's like capped at like 120, but so it's not gonna like blow your GPU out like the current EmberGen does. You can only use EmberGen on one GPU. you can keep older builds installed if you go to our website on the downloads page. And you can install what we call a portable version, and you can just put it somewhere else. Yeah, VFit or VDB import is probably going to come, but that's probably EmberGen 2.0 or something. Yeah, unfortunately, EmberGen can't save to files on like a server or read from it, because what happens is like we're streaming the data like to the graphics card, and for whatever reason, whenever you stream that data or you try and like write to a cloud server, something with like the Windows operating system happens, and it goes, oh shit, like we've stalled or whatever, crash the program. It's basically what happens. So it's more of an OS problem than an us problem due to the way that graphics cards work. That's my understanding of the problem. I think we're trying to look into it to see if there's a way that we can fix it or add like, you know, certain pauses in the middle of the way if you are writing to like a network drive, but I don't know exactly what our solution is going to be, if any. Just due to everything being on the GPU and us having to get it off. Why not release sparse without lighting? Because it's completely unusable right this second anyway. Almost nothing works. There's no control over the simulation or anything. All we can do is just inject velocity. So sparse is a long way away from working. Yeah, so that's basically it, guys. I don't have anything else. I hope that you enjoyed the stream, and hopefully you learned something. And I think we did some pretty cool stuff with smoke shading, and especially the fire shading, and you know, kind of showing you you know, how you can use these new particles to really spice up your workflow. And it's going to be amazing to see what you can do with these new particles. And you know, one thing that I'll show just kind of as the exit, which I do this shit all the time. Like I'm like, the stream's ending, and then I just don't end it. But where we have just this, so this is kind of like some really high quality stuff that you can put out with the new stuff. So this is like you know high quality renders, and like especially the smoke stuff right here. It actually, look at me being dumb with my camera blocking everything. Here, we'll restart it. So there we go. And so we've got this right here with all these particles, really high quality, and especially the smoke. Like I said, I mean my GPU was crunching that stuff, and so you can get some really high quality renders out of EmberGen these days if you have a 3090 and the additional power to play with, and it just looks great. So and hopefully we'll include some of this stuff as presets, and I'll have some tutorials on getting really good smoke lighting and shading like that, and just show you how to get this kind of detail. And I'll probably even show you how to get these beauty shots of the camera animating and that kind of stuff, because it really adds to the finesse of the simulation. So yeah, so that's it. I'll catch you guys later. Thanks for checking in, and thanks for your support. If you've purchased licenses and stuff like that, we love your support. We have 16 people on the team, and if you go buy a license, if you don't have one, you can get access to this stuff now in our Discord server instead of waiting who knows how many months or whatever for 1.0 to come out. So if you want to play with it, buy a license, and you can. So thanks for your support. Bye guys, I'll catch you later. Thanks for joining me. Now the awkward part where we end the stream.